So let's start with the problem A. The problem A says that we have t integers on the board. So, and there is an important integer n among them.
Time limit
And
for test. 1 second.
hello, can you please pause yourself? Pause your mic. Yes. So there are basically t integers, and uh, there is an important integer among them. So the integer n had a form of 10 raised to power x, and the symbol denotes exponentiation. So most of you must have got the question, and the symbol was missed. So the power symbol was missed while writing the integer n. So basically, we have to find. We will be given uh, some integer as test cases, and we have to find uh, if they can be an important integer or not. So basically, for the condition for an important integer, we'll just discuss. The problem is says there is an n which is of the form 10 raised to the power x, and here x is greater than equal to 2 as per the question. So this symbol is missed. So basically, whatever, if n is an important one, then whatever is the uh, form of n, it should start with 1 0. That is a basic necessity. And there must be an integer x written after it, which should be greater than equal to 2. So it should start with 1 0 definitely, and should have an integer x after it, which should be greater than equal to 2. So the way we should approach this problem, uh, I think it will be better for us to consider n as a string, because we can easily find that if n is taken input as a string, uh, then s0 should be equal to 1 and s1 should be equal to 0. So this is the first condition, because the starting two uh, letters of that string should be 1 and 0, because the number is of the form 10 raised to power x. And after that, x. So after that, whatever is left, we should just, whatever is left except this 1 and 0, this thing I'll just call it as string t, this part, except the 1 and 0 part. So this should not be empty. It should be, as it is given that it should be greater than equal to 2. This should not be empty, and this should not start with 0, not start with 0. With 0, because if it starts with 0, I'll just show you a test case. 1002. 1002 is the test case where I'll just show 10. The
Sir,
10 part is fine.
hello, sir.
Hello.
Sir, question understanding or can you explain once?
Okay, I'll just explain again. So I have some integers. Okay, I have some integers. Basically, we have to check whether I have some integers. Okay, this will be the form of the integer 10 raised to power x. But that symbol of the exponentiation is missed. So basically, we are left with something of the form 1 0 and then some integer. We have to check whether the given integer is of this form or not. Okay, so to check that, we input the n as a string, and the first character should be 1, and the second character s1 should be 0, because it has to match this form. Did you get it?
Yes.
Okay. So the left out string, whatever I was telling, it should start with 10, and the left string, I'll call it T. The left out string except the first two characters. So basically it should not start with 0, because if x is a number, it should never start with a 0. And also it should not be equal to 1, because x is greater than equal to 2, it's given. So x should not be equal to 1. This is a failed case actually. This should not be not equal to 1. So this will solve the problem. First of all, I'll just uh, go through it again. It's of the form 10 raised to power x. This symbol is missed, the raised to power symbol, exponentiation symbol. So the number we are left with is of the form 10 for the 10 and the x. And it is given in the question. I'll just show it here also, that x is greater than equal to 2. So since x is an integer, it should never start with 0. Its starting character should not be 0. And it should not equal to 1. Exactly 1 it should not, because x is greater than equal to 2. Everything else will satisfy the condition. So I'll just show you my code for this problem.
Okay, so in short, the third index of the string should not be 0 or 1. Am I correct?
Exactly.
Hello.
It can be 1, it can be hello.
Yes, sir, yeah, please.
It can be 1, but it should not be just 1. After
Oh,
1, it can be 10 or 102 for the one case, and it should not start with 0. So third character should not be 0, but third character can be 1, and after that something must be there. Exactly 1 it should not be. Okay.
okay. Okay. And also, like, what if only 10 comes?
Only 10 comes, it will not be, it will not be treated as a valid case. It will not be a
Okay,
valid
sir.
number.
Yeah, got
Okay, so I'll just go through the code quickly. If n is less than equals to 2, so basically the length of the number is less than equal to 2, then obviously no answer exists, because you cannot have 10 and after that you have something. So it cannot be fit into less than equal to 2 length string. So next up, the condition is the first index character should be 1. So, and the second index character, or I'll say 0th index should be 1, and first index should be 0. So it has a starting with 10. So I'll just create another string, and that is the remaining part of S. This S1 is the remaining part of S. I'll start the loop from 2 and up to n. And this is actually representing the remaining part of S, except the 0th and the first character. And S1 should not equal to 1. Exactly the one string is not applicable, because it should be greater than equal to 2. And it should not start with a 0. So the remaining string from the third character onwards should not start with a 0. So basically, if it occurs, I'll just print no. And otherwise, everything else will do. And if the starting is only not 1 and 0 of the initial string, then also I'll just print no, because it has to be of that form. So any doubts you can ask me with this question. If you have any doubts, you can ask me. You can just unmute yourself and just ask me. Okay. Okay, somebody, I'll just look at the chat one. There are some other approaches as well. So definitely, if it works, you can see it yourself. Why is it working? Or there can be multiple implementations here. So uh, that is fine if you do it in another method or take it and as an implement. I just discuss the idea. What is the question asking and what you have to do. Basically, implementation part is that you can do anything of yourself. So everybody is clear. I'll just move on to the next question. Okay. The next question that is saying there is a bus consisting of n seats and they are numbered from 1 to n, and the passengers are advised to sit in a specific order only and following following a specific algorithm. So what is the algorithm? If there are no occupied seats, the passenger can sit in any free seat, and otherwise if there is any occupied seat, then he should uh, sit. If he sits in a sit, so either the right seat of it should be occupied or the left seat of it should be occupied. So basically I'll just explain it with the diagram also. So the question gives the order of the seat numbers of the n passengers that they occupied, that is given. So the which passenger occupies which seat is given actually, and we know the array A, which is the seat number of the each passenger, and they follow the order. That is, first the first passenger comes in, then the second passenger comes in, then the third passenger comes in. So like this we have to go. Okay, so I'll just take up an example and just explain it once. I'll just take this example, 5, 4. So this is the seating order. So first, this is the first index, first passenger. This is the second. This is the third, fourth, and fifth. So the passengers comes one by one, and there are n seats available also. This is first, second, third, fourth, 5 seats are available, and 5 passengers come one by one. And the seat numbers occupied by them are all distinct. So one passenger cannot, two passengers cannot have the same seat. So everybody has a different seat. So basically, first everything is empty. So according to our algorithm, there are no occupied seats in the bus. So he can occupy the free seat, any free seat. So first passenger comes and tries to occupy the fifth seat, and we'll just give him this seat. We'll just give him this seat since all the seats are free. We can just give him any seat. So next, the second passenger comes. He wants to occupy the fourth seat. Since A2 is 4, so he wants to occupy the fourth seat. So for the fourth seat to be occupied, we have to check whether either of this either of the fifth or the third seat should be occupied previous. Then only he can sit for the fourth seat. Otherwise, if both of them would have been unoccupied, then he could not sit at this, and we will print the answer no. So we'll check for 5 and 3 index seats whether they are occupied or not. If one of them is occupied or both of them are occupied, then fine. I'll just give it the seat. So second person sits here. First person had already seated it. So now the third person comes in. Third person comes in and he wants to occupy the seat indexed 2. So now when he wants to sit in the 2th seat, so second seat, so I'll just see the seat number 1 and seat number 3. Seat number 1 is unoccupied. Seat number 3 was also unoccupied. So if these both are unoccupied, he cannot sit in this seat, and we'll just say this arrangement is not possible, and the answer will be printed as no. So this example is clear, I think. I'll just take another example for which the answer is yes. This one. So I'll just take another example. 2, 1, 3, 4. This is the first passenger. This is the second. This is the third. This is the fourth. Now we have 4 seats. Third and fourth. So first passenger comes in, and since all the seats are unoccupied, according to our algorithm, I'll just show it again. If there are no occupied seats, the passenger can sit. Okay, so there's no problem for the first passenger. The first passenger sits in the second seat. Now comes the second passenger. He wants to sit in the first seat. This is 1, so he wants to sit in the first seat. I'll just check the right and the left. Right and the left. Left, there is no seat, so I'll just not check there. I'll just check the right. This is occupied, so he can sit here. Now the third passenger wants to sit in the third seat. So since the left seat of the third seat, which the third passenger wants to occupy, is already occupied, this one is already occupied. So third one can also sit right here. And then comes the fourth passenger. Since the third seat is occupied, to the left of the fourth seat, he can occupy the fourth seat as well. So this is a possible arrangement because all the passengers can be seated. All the passengers can be seated in this order. So I'll just go through the approach that should be used for this problem. So I am just given an array A1, A2, A3 up till AN. So first passenger always can sit because A1 when A1 comes or the first passenger comes with a request to sit at the A1th seat, so he can just go and sit because all the seats were unoccupied before. So whenever the passenger A1 comes, I'll just give A1th seat to him. And when A2 comes, I'll just the second passenger wants to go to A2 seat. So I'll just check whether A2 minus 1th seat and A2 plus 1th seat. Actually, for the general term, it should be AI plus 1th seat and AI minus 1th seat. I'll just check this left seat of the seat that the passenger wants to occupy and the right seat. If any of them is occupied, then there is no problem, and I'll just occupy the AIth seat for the ith passenger, or in this case for the second passenger, I'll just reserve the A2th seat. Any of them is occupied, then fine. If both of them are not occupied, this implies this is not a possible. This is no answer, so not possible. So I'll just, anyone has any doubt with the approach? Let's discuss the code later. Anyone has any doubt in the approach, you can ask me by unmuting yourself. Okay, so I'll just move on to the code then. If anyone has any doubt, you can unmute yourself and ask. So basically for any AI, I'll just check the AI minus 1th seat and AI plus 1th seat. If any of them is occupied, then I'll just occupy AIth seat. Then occupy AIth element. AIth seat. If any of the left or right seats are occupied. So I'll just show you the implementation also. So first, I'll just take n and I'll just take an occupied array. I have declared it as an n+2 size array. We'll discuss why. So it will be better. It can be done better with an n+2 sized array rather than taking n sized array. So first I'll just loop from 1 to n. Suppose this ith passenger wants to sit at the seat number x. So if I equal to 1, which means he's the first passenger to sit. So I'll just occupy the xth seat for him. If he wants to occupy the xth seat, I'll just occupy it for him because that won't be a problem because he's the first passenger. And after that, if he's the first passenger, I'll just continue as well. So after that, if the ith passenger comes in, I'll check whether the x minus 1th seat, he wants to occupy the xth seat. So I'll just check for the x minus 1th seat and the x plus 1th seat. If either of them is occupied, so if I'll just mark 1. For the occupied seats, I'll just mark 1. So if this or this, so if any of them is 1, this or will become 1. So condition is satisfied and the ith passenger can sit. And I'll occupy the seat number x for him. So occupied of x will also become 1. Otherwise, if this condition is unsatisfied in any of the passengers, for any of the passengers, that I'll see that if he wants to occupy the xth seat, I'll see that if x minus 1th seat is also unoccupied and the x plus 1th is also unoccupied, so then there is a failure and I'll just print no. So I have just created a flag variable and I'll just mark it as 1. So if flag was marked as 1 after the loop completes, if flag was marked as 1, then obviously answer will be no. Otherwise, yes. So if flag was not marked 1 for any of the passengers, then that's fine and I'll just print yes. This is a valid arrangement. So did anybody have any doubt in this? You can ask me.
ये if I is equals to 1 क्यों लिखा हुआ I double equal to हाँ वो क्यों लिखा
yes.
हुआ
So for the first passenger, the algorithm says that for the first passenger, everything is unoccupied. So for the first passenger, when he comes in, he can occupy the seat. That is given in the question. I'll just show you.
Okay, got it.
That is the first passenger. So I equal to 1 is the first passenger. So for that, a special condition has to be applied. Anybody has any other doubt? Okay, so I think it's fine. So now I'll just discuss the third question. For the third question, we are given an array. So initial array A is given, and this is called the template array. So template array A is given, and there are n integers in the template array. Okay, so we are also given m strings, and each consisting of only lowercase letters. So that is fine. The strings are numbered from 1 to m. So there are the m strings, and they're numbered from 1 to m. And a string s is considered to match the template. So we have a template array and we have a string. So we have m strings, and for each string we have to check whether it matches the template or not. So what is the template matching condition? That should be the length of a, the string length should be the number of elements in the array. So the array length and the
कोड फोर्सेसच्या डिव्हिजन 3 मध्ये किती होता 4 क्वेश्चन झाले
So
जो त्याने टॉपिक होता ना फोर्थचा तो एक्झॅक्टली हे होता प्रिफिक्स समचा होता जो म्हणजे
can you
आता
please put your mic off? Anybody who is speaking. Okay, fine. So for a string to match the template, its length should be same as the array length A, and the same numbers from A correspond to the same symbols from S. So basically, we have to see this condition. If for any pair of index I and j, if ai equal to aj, means the numbers are equal at that position, then their letters should be equal at that position for the strings as well. So if the numbers are equal at two positions, suppose I and j, or wherever there are equal numbers, then there should be equal characters at that string position. So basically this is the condition. And whenever same symbols are there at two positions, so there are same numbers at that position as well. So basically there is a one-to-one correspondence between the characters of the string and the elements of the array. So I'll just discuss it with the help of an example. Just take this example. Initially, we are given a template array, which is A. So we'll just see what are the equal characters. What are the equal characters in this array? This 3 and this 3 is equal. Otherwise, everything is different. So whenever a string comes in, we have two strings in the query. So this is query number 1 for the first test case. And this is query number 2. These are the m strings we have. So we'll solve first query number 1. So what is happening here? We have this template string, template array. Here, these two numbers are equal. So at these positions, like this, you check the string, these positions, the letters are also equal, A and A. So this is fine. Now all these letters are different. So here the numbers are also different from each other. So basically this is following the template string. So this is following the template string. So answer for this becomes yes. Because wherever the positions, whatever the positions where the array elements are equal, there the string elements are also equal. And for the next test case, we'll see just these two positions are equal. That is fine. That is fine in this case also. That elements are equal. These two string elements are also equal at those indexes. But here, observe that this f is also equal to this f. So basically, and this 1 is not equal to this 5. So basically, we do not have this same structure or the same template here. This f is equal to f here. So these two indexes, if I choose, here the string elements are equal, but not the array element. So answer for this will be no. So for all the string elements, wherever they are equal, those indexes should reflect in the array as well. So I'll just go through the approach now. I'll just take another example for better understanding. So I'll just take the third example, 5 minus 3, 5 minus. So basically these two elements are equal. So here the string character should be equal, whatever they are. They might be A, B, C, something like this. So whatever they are, but these two positions should have a same character. And these two positions also should have the same character. But since this is minus 3 and this is minus 5, these two should have a different character. So this and this should have a different character, but these two should have the same character. This 3 and minus 3, the second and the fourth index should have the same character, and first and the third index should have the same character in the strings. So basically, I'll just see A. So basically, the second and the third character is same. So the answer should be no. B C. This is fine. This is going well. This is the ABA has a length of 3, but the array length is 4. The first condition is also no. So this will also work fine. So if you can check the examples yourself. I hope you have got what is the question is asking. So anybody has any doubt about what the question is asking? You can unmute yourself and just ask.
Sir, what will be the worst time case complexity?
For the previous question, okay, I'll just discuss the time complexity for the previous question as well. Previous question, I'll just show you my code for the previous question once more. And I'll just discuss for this as well at the end. So previous question, I just looped over n and taking the input, and I have a O of 1 check. So previous question time complexity was O of n, because I just took the input and just for each input I just did a O of 1 check, and I looped over all the passengers. So previous question of n was the time complexity. Here we'll discuss the time complexity in a while. So I'll just focus on the input constants as well in the third question. The third question, we have the elements of the array which has a size n. So we'll take input of a size n array, and we are given m strings first of all, and the sum of the lengths of the strings which we are given, that will not exist 2e5. So all the strings which we are, all the m strings, if we sum their length, then also it will not exist to exceed 2e5. So basically we can loop over the strings as well. So that won't be a problem because total length will be less than equal to 2e5. So I'll just discuss the approach. What am I given with initially? I'm given with an array A. So wherever the elements are equal, those indexes should have the same character in the string as well. So basically, suppose A1 value occurs at 1th index, it will definitely occur in the 1th index. Then suppose 4th index. So A4 equal to A1. So if A4 equal to A1, I'll just mark it like this, and A6. Then A1 value occurs in these indexes. Suppose A2 equal to A3. So A2 value occurs at 2th and the 3rd index. So in these indexes, the string characters should be also be same. In these indexes, the string characters should also be same. So, and suppose A5 is different. So A5 occurs in the index 5. So we can maintain a map. We can maintain map of integer from a vector. What will this map do? This map will just take the value of A1 and push 1 into it. So basically A1 occurs at the first index. So I'll just find this for this integer, it will map the indexes where it is occurring. This integer is occurring. So I'll just, for each I, write the algorithm as well. Suppose this map, this AI value is occurring at the ith index. So wherever the AIth value is occurring, all the indexes will be stored in this map of vector. So basically we have these indexes stored like this. This will be the vector for, this will be the vector for A2 and A3. Whenever a string comes up, we will also note that another important thing, the value of this index, this key, is not important. This value is not important. We just have to maintain that these three indexes should have the same character. So while checking the string, these three indexes should have the same character. And these two indexes should have the same character. This one should have the same character, because, but this value, whatever it was, maybe this was -5, A1 was -5, A4 was -5, and A6 was -5, or some other value, that doesn't matter. Whatever the value, X, it doesn't matter. But these three indexes, since they're equal, we have to consider, whenever we are considering the string, the characters at these indexes should be equal. whatever the value of a1 or a2, that doesn't matter. So we are just concerned with these vectors. What are these vectors? The positions where the numbers are equal. So we are concerned with these vectors only, and not the value. What was the value equal to at these positions? That is not important. More important thing is that they were equal. So I'll just store these vectors in a vector of vectors. These vectors are important. So I'll just store these vectors in a vector of vectors. So the space complexity is still O of n, because the sum of the lengths of these vectors is n, because a index can have and go into only one key. So suppose a fourth value, this fourth index will come into one of the a4th. A4 is, since a4 is equal to a1, it will go into the vector of a1. So 1 and 4 will come in the same vector. So total length of all these vectors is total length is still n. So don't confuse it. Total length of these vectors still n. So these vectors are important. So next, the string comes up. A string comes up, S12, S1, S2, S3, like this. M strings comes up. And for the first string, suppose this was A, B, F, B, A. So I'll construct the same thing for the strings as well. This will be now map of character, vector int. Okay, first we'll check the length of the string. If the length of the string is not equal to the n, which is the length of the array, then obviously the answer for this will be no. And if not equal to n, then answer is no. Otherwise, I'll just create the similar map for this string. For creating this map, I needed a time complexity of n log n, time n log n. For we require time n log n for the array part. For the string part also, I'll just, for a occurs in the first position and the fifth position. So for the MP map of A will contain this vector 1, 5, because A occurs in 1, 5. Similarly, map of B will contain only the index 2. Map of F. Like this, we'll just construct the map for each character. F should be 3, and map of character B is the fourth character. So I'll just construct the similar map for the strings as well. So now, again, this letter is not important. Whatever it was, A or C, it can be C as well. So this letter is not important. Important is these vectors. 1, 5, 2, then 3, then 4. If these vectors are equal or match with the vector of the initial array, then we'll say that yes, answer will be yes. If we create a vector of vector and push back these vectors into this for the strings as well, if the vectors match, then we can say that yes, the answer is yes. Otherwise, answer will be no. So anybody has any doubt about this approach? So you can ask me. Did everyone get it, what we are trying to do? Okay, so these vectors should be matched. So I think everyone got that. So how are we matching? So I'll just show you the code as well. So you'll get an idea how we match. So keys don't matter. Yes, keys don't matter. These vectors should match the vectors of the array. So now how will we match? That is the implementation part. I'll just show how we will match the vectors. So initially, all the vectors of the initial array were pushed back into a vector of vectors. Into a vector of vectors. And now for the each string, we'll also create a vector of vector for each string. And it will store these vectors. Now we have to match this vector of vector with the vector of vector that was formed using the initial array. So suppose you are given two arrays. Suppose I'll just move on to another question and say you are given two arrays, A1 and A2. These are arrays. So basically, if we want to check whether these have the same elements or not, so we can just sort both the arrays and just check whether they are equal or not. After sorting, they will become equal. Suppose I say that 2 2 1 and 1 2 2. These are two arrays. And after sorting, both will become 1 2 2. So this is how we can check the array part, if they are equal or not. So if two arrays, if they have to be checked whether they're equal or not, so we can just sort the elements, or rather they're equal. I won't say equal, the arrays are equal, but we will say the elements of the array are similar, means the frequency of each element is same. So we can just sort and check. So similarly for this vector of vectors, to check these two vector of vectors, vector of the string and the vector of the of the initial array, we can just sort the initial vector of vector and sort the vectors of the strings as well, and then compare these two. If they're equal, then obviously all the elements were equal in order, and so that works. So everybody got the algorithm? How will we solve this question? If you have any doubt, you can ask me. Just unmute yourself and ask me. So the time complexity, I'll just discuss for this as well. The time complexity, okay, I'll just go for the code. I'll just go for the code and explain it. Yeah. So everybody got the approach, I think. If anyone has any doubt, you can ask me. Okay. Now I'm taking the input and I'm just pushing back the indexes where AI occurred. So MP of AI, I'll just push back I into it. So basically all the indexes where that value occurs is pushed back. And I have just created the vector of vector in for the initial array. I've created the vector of vector in for the initial array. And since the key is not important, important part is the vector formed by that value. So I'll just push back the second or this vector of the map, the value of the map. This is a vector. So I'll just push back this value into the vector of vector, and I have just sorted it for the checking part when I come across the strings. Now I input m and I take the strings one by one. If the string length is not equal to n, then okay, answer is no. I'll just move on to the next string. Otherwise, I have created the same string or the same map for the string as well. And I've just marked the indexes where this character, the particular character occurs. So again, I have created a vector of vector for the string, just like the array part. And since the key is not important, I'll just push back the second or the value of the maps into this vector of vector. And again, I'll just sort this one as well. I sorted the previous one and I've just sorted this one as well. If these two are equal, okay, so then the answer is yes, otherwise no. So everybody got the code. If anyone has any doubt, you can just ask me. I'll just go through the time complexity as well. So this has a total time complexity of n log n because I'm just pushing back into the map. So total n log n step. Again, this one also has a time complexity of n log n because the sum of the vector lengths in the map stored as the value. So the sum of the vector lengths is always n. So that is also, and again, then I sort it. So that is also n log n. And for the string parts, if the string length is not equal to n, I'll just simply answer no and continue. Otherwise, I'll just take the string and same procedure I'll just do for the strings as well. So again, a complexity of string length into log of string length, or rather, if the string length is n, again n log n. So for the strings. But one thing to note here is the sum of the string lengths will be less than equal to 1e5. So this will work in 1e5 log n. So total complexity may reach up to 2e5 log 2e5 in the worst case. Because some of the string lengths into this factor may go up to, or rather, if if the array is long enough, so that can also be n log n complexity. So this is the time complexity for the third problem. Now I'll just move on to the fourth problem. If anyone has any doubt with the third problem, you can ask me. Anyone has any doubt? Okay, so I'll just move on to the fourth problem. Now here,
Sir, can
we
you
have,
repeat why are you shorting?
okay, so I'll just repeat one. Okay, suppose the initial vector we get, that is something like this. The vector of vector I'm talking about. Sorry, this cannot be 1, 2, and this should be 3. This is the initial vector of vector. And for the string, I get the vector of vector like this. So basically, if we see, if we rearrange the elements, then they're equal. So these, if I directly compare, these two vectors are not equal because element wise they are not equal. But when we sort, the order of the elements are will be the order will be same. So if they were if the elements of the string can be rearranged to form the elements of the vector of vector initial vector of vector, then the answer will be yes too. So in this case, this can be rearranged here and this can be rearranged here. So did you get
Okay.
why we are sorting?
Okay.
These two vectors are actually, we should consider these as equal. So we need to sort first. Do you get?
Yes, sir. You can continue.
Okay. So anyone else having any doubt? Okay. So I'll just move on to the next question. So there are n cells and numbered from 1 to n. And in each cell we have a value AI and a letter SI. So every cell has a value and a letter. And all SI are either L or R. So this is fine. Now what we have to do is we have to maximize the score. So what is the score? I'll just see what is the score defined as. We have to maximize the score. So whenever so in one operation we can choose two indexes L and R. So left and right index we can choose such that SL equal to L and SR equal to R, and add the values AL to AR to the score. So we start with a score 0 and we can choose any index L to R and add the value AL plus 1, or rather the range sum from L to R to our current score. And then just replace SI with dot. So we cannot choose this L and R again. So this L or R and this L and R cannot be chosen again because SI is replaced with a dot. And we cannot choose it again. So basically, this is the question. Now I'll just show it with an example again.
-1. So any questions on the problem statement first?
Okay, so anybody has any doubt with the problem statement? We can just choose two indexes left and right such that SL equal to L, and this condition should be satisfied that SR, whatever the indexes we choose, the value of the string, the character at that particular index should be L and R respectively, and we can just add the score. And we have to mark all the indexes from L to R with a dot. So we cannot choose anything in between again. So basically, I'll just show you it with the help of an example. Suppose okay, I'll just show you the example. This last example seems good, so I'll just take up this example. This is problem number D. Now let's see what is the question saying. So basically, if we choose this, I can choose this and this as my L and R. So if I choose this, then I have to mark the string elements like this. So basically, entire string will be filled with dots. So I cannot choose any more things. So what will be my score? All the sum of the values in this range. So this score will be 15 from 1 to 5. But look what we can do better. We have this string. We can choose this first. This and this third index and the fourth index. This, if we choose this as L and this as R, we get 7 score. And the updated string becomes like this. These two indexes become void. And now we can choose this. And again, a 15 will be added. So basically, we are getting 22 as the answer. First, we'll choose the third and the fourth index. That will add 7 to the answer. And then we can choose the first and the fifth index. That will add another 15 to the answer. So basically, total score will become 22. And I have to maximize the score. So did you get what the question is saying? So basically, when we are taking the third and the fourth index, everything in between has to be marked as a dot. And I'll just add it to the score. These elements, the sum of these elements will be added to the score. So updated string becomes like this, and we add 7 to the score. After that, I'll just add 15 and make it 22. So maximum score becomes 22 in this case. Okay, I'll just do another example. Example was simple enough. So I think other examples you can figure out. So I'll just go through this one as well. Another example would be P5. So now for this, we can choose these two index first, and they will become void. And after that, we can choose these two. But the better would be to choose this L and R, and we will get the entire array sum. So that will be, I think, 18, I think. So we can try out other combination as well. This would maximize the answer. So everyone is fine with the question? What is the question asking? I'll just go into the solution in a while, but are you clear with the question? What is score and how we can change the score and add numbers to the score? Okay, so now I'll try to explain you the solution. So we are given an array A2, A3, A4, and we are also given an we'll just Okay. So we are given an array, suppose this and a string as well. So what we can do, suppose I choose this L. Suppose I choose this L. Suppose this has an L value and suppose I choose this L. What can be the maximum? I'll just add 8 and just put L. What can be the maximum sum or the addition to the current score that can be done? This can be done whenever I choose this R. So the rightmost R and the leftmost L will do the highest sum addition to our score. So this is one thing to notice. So for the score addition, we can just take the leftmost. It is preferred. If I can do this, then it's fine. Again, if I have taken this score, but if I take this L to R, all the in between things will be marked as dot. So I cannot take anything else. But we'll just do it a little intelligently. So for this L, if we have already taken this R into consideration with that L, so what can be the maximum? This R. So for this L, this R will work. I'll just mark it as 1. This is also 1. This is a 2. This is a 2. This is 3. And this is 2. So if I do it in the reverse manner, first I choose this segment, then everything is marked is marked dots. But then I can choose this segment as well, because outside this nothing is marked dot. This thing will become dot after I choose this segment. So I decide the segments first and I will just go outward from them, not inwards, because if I choose the outward segment first, then inward segments cannot be chosen because all of them will be marked dots. So how can we choose segments such that the sum is maximized? So for that, for the leftmost L, I'll choose the rightmost R. For the leftmost,
Shubhankar, what was your previous deduction that you did? Like we cannot start from inwards. What was the
okay,
reason?
so basically if I start with A1 and A7, okay, so everything in between will be marked dot as per the question.
Yeah.
And I cannot choose anything in between. And additional parts cannot be added to the current score. So this will be my total score. So that is not desirable. If I start from inverse point of view, then okay, so these three might be marked dots, but after that I can choose these two because they are still L and R, not dots.
But we can continue to iterate. Say, example, we maintain two different vectors, L and R, with their indexes. We can continue to iterate from the leftmost side of the L, marking it with the furthermost rightmost R, and going inwards. Right?
Okay, so if I take this and this is the rightmost R, okay. So if I take these two,
Mhm.
if I take these two, all of them will be marked dots.
Yes.
So
But for computation, I'm saying, like,
yes, for computation, I'll just do it. But for the if I tell you the sequence of operation, I
that
should
will
do
be
it from
reverse. Yeah.
should be outward to inward.
Yeah.
Sorry,
But we're
inward
getting
to
the same
outward.
result, right?
Yes, we'll get the same result, but operations cannot be done in a reverse manner as per the question. Because if you go from outward to inward, outward operation would just put everything dot and you cannot do the inward operation. But actually the answer will be maximized if we'll do the operation from outward to inward. Sorry, inward to outward. The answer would be maximized. So for calculating the answer part, you can do it from anyways, you can do it. You can just pair this up. This L and this R you can pair up. This L and this R you can pair up. So you're getting my point. The sequence of operations should be from inward to outward as per the question. To maximize the answer. Otherwise, if we consider the outward part or the larger indexes or the larger indexes first, then we cannot go inwards. So, did you get it? Whoever was asking.
Yes.
Okay. So, I have to just take the leftmost L, leftmost L and rightmost R, and just add the range sum from L to R to the score. Range sum from L to R to the score, and just move on to the next L. Move the to next L and move the pointer to previous R. So basically we will use a two-pointer approach where the lower pointer, the two pointers P1 and P2, this is the lower pointer and this is the higher pointer. This will mark to an index where the character is L, and this will mark to an index where the character is R. And we will just, if this condition is satisfied, we'll just add it and increment the P1 and decrement P2 for the next sum that has to be added to the score. So this will maximize my score. So we just use a two-pointer approach such that the lower pointer is marking to L, higher pointer is marking to R, and we can just do it like that. If lower pointer marks to R, we'll just move to the next pointer. We'll go on until we find L. And if the higher pointer marks to L, we'll just decrement. And if the lower pointer marks to R also, then we'll just increment the lower pointer. So are you clear with the approach that we are going to follow?
L and R case was, what was the next two cases? Say example, there is no R and you are sitting on some different thing.
If we are at pointer P1 and it is marking to an R, so we don't want that. We want the lower pointer to be L and the higher pointer to be R. Because
So we'll
then only
increment the lower pointer and
exactly.
reverse.
If yes. And if they are L and R, then we'll just add it. Add the range sum from L to R, the range sum from P1 to P2, range sum from P1 to P2 to our score. And then again just increment and decrement this right pointer, higher pointer. So everybody is clear with the approach, or do you have any doubt you can ask? Okay, so I'll just go into the coding part. Okay, so I've just taken the input array and I've also calculated a prefix sum. So why this prefix sum is needed? For this prefix sum is needed for the range summation part. We can just access the range sum that has to be added quickly. So and then I take the string which we are given. For to make it one indexed, I just add a space before the string for it to be one indexed. And then I'll just take 2 pointers, P1 and P2. P1, I'll set P1 as 1 and P2 as n. So P1 is at the beginning and P2 is at the end. Our current answer is 0. So we start with 0. And while the smaller pointer is less than equal to the greater pointer, so we have 2 pointers, and while this this P1 is lower than P2, we will check 3 conditions. If P1 equal to the position, if the character at position P1 is L and the character at position P2 is R, so we'll just add the range sum from P1 to P2. That can be done as a prefix sum up to P2 minus prefix sum up to P1 minus 1. That is added to the answer. And we'll just increment P1 and decrement P2. Otherwise, if the character at the P1 or the lower pointer should always mark to an L, not a R. So if it is marking towards an R, we'll just increment the lower pointer. And if the higher pointer marks to an L, we always want the higher pointer to mark at an R. So if it marks to an L, we'll just decrement the higher pointer. So this is, and the final answer can be printed.
It should be P1 less than P2, right? Equals.
Yes,
is not
because
required.
equals is not required. Definitely, you're right. Because if equals is satisfied, then then this condition is not satisfied, and either of these conditions are satisfied. And in the next iteration, we'll just go into P1 less than P2. So
Yeah, one loop will be.
yes, one
Skip.
loop will be vested. Yes, right. So basically, this will also work fine. P1 less than equal to B2 will also work fine. So are you clear with the approach, what we are doing? If the lower pointer marks to an L and the higher pointer marks to an R, yes, we add that range sum. And just increment the lower pointer and decrement the higher pointer. Otherwise, if the higher pointer marks to an, or the lower pointer marks to an R, we do not desire that. We want the lower pointer to mark to an L. So we'll just increment the lower pointer and we'll just try to find an L. And if the higher pointer marks to an L, that is also not desirable, and we'll just decrement the higher one. So did you get what we are doing? Or if you have any doubt, you can ask me. Again, for this code, the time complexity is O of n because we are maintaining 2 pointers. And for the prefix sum part, we also require a time complexity of O of n. So this is overall O of n time complexity. So time complexity O of n. Space complexity, we use a prefix sum array, so that will be also O of n.
Shubhankar, another thing,
Yes.
just apart from this one, like in contest, like how do you prove greedy? Is it always an intuitive or take examples and prove for some cases, or what is the approach in your case?
Okay. So for the greedy problems, you can just take the examples. The fourth example that I explained was good enough that this example, I think, yes. This in this example, we can see that taking from an inward range to an outward range works. So yes, definitely you need an example to find that what could be the solution. And try to once you try a greedy, try to find whether we can do better than that as well or not. We can do
Okay,
something
so
better than that or not. So
prove by examples and try to find counter examples. Okay.
yes, exactly. And if the question, if the question, suppose you are not getting answers with the greedy, then it might involve another approach or some better greedy or a DP approach. So then you can think of other approaches. But fi- for for the first time, you can just try to maximize the answer by this way and see if can we do better with some other approach or not. If we are not able to come up with something better, then this might be the answer.
But like
Yes,
that's the possible.
definitely proofs are
Much better,
really
but not
uh,
time.
yes, difficult to come up during the contest, but you can just do it after the contest. Why is your greedy working?
Oh, got it.
Fine. So you can just think upon it after the contest. Why
All
is your solution working or like that? If you do have time constraints, you can just code up the greedy and try.
Sure, understood. Thank you.
And if you can see that you are doing something better with some other approach, then definitely the previous approach was wrong, right?
So you drop the entire approach or like start from scratch?
We can just go on to some better greedy approach or rather
Mhm.
DP approaches when we are not getting anything. If we think in the line of DP, can we solve the question with a DP approach or not? So
But sometimes what happens if we found counter examples, we try to incorporate with say special cases in the fails approach
yes,
instead of drop. Mhm.
mostly if special cases, if you are creating a lot of number of special cases, then probably you are going wrong. If there are one or two cases that are obviously missed out, or you can see that yes, they have to be explicitly mentioned, then you can just mention them. But mostly, if you are creating a lot of cases, or rather a lot of casework without proof, so that can be a indication that you are going wrong. You're trying
Understood.
to incorporate every corner case, then maybe the approach is wrong and you should think of something else.
Got it. Yeah.
Okay. So
I can
everybody was
check
clear
the
with this
chat.
approach? Sorry,
Can you please check my question I have asked in the chat?
can you tell it?
Sure. So if I am storing all the indices of L and R
Yes.
and I'm reversing R, like it's similar to yours only, right?
Yeah.
So how do I? But I was not able to come up with the answer with that. Can you just explain in the way you're writing
Okay.
that only?
Okay. So you took wherever the L's are coming, you took
Yeah.
those indexes, and wherever the R's are coming, you are using a reverse sorted. So
Yeah.
okay. So first you take the first index from the L array,
Yes.
and then you take the last index from the, or rather the
I
first,
mean,
because
yeah, the first
you have
index of
reversed.
the second array,
Yes.
and then I
Yes.
can calculate the prefix sum of that.
Exactly. You can calculate the
But
prefix sum.
what? But when these two arrays will be like either one of them will get finished first, right? Depending on the count
if
of L and R.
if one of them, if the one of the indexes, suppose the Lth index exceed the Rth index, okay,
Yeah.
then you should stop at that point.
But with that, I guess my like I could not get the answer. I'm just pasting my code, like very short code. Like if you just check,
Okay.
if you see, uh,
I also
if
took a
I
similar
stopped
approach.
after,
You can check.
but I did not get the answer right.
Okay, so for the code
Okay,
part, you
okay.
can ask in the doubts of that, but the basically approach is correct. Whatever you are using is correct. So maybe there is some error with the code. You can ask in the uh, doubt section and or in the Discord channel for the code part. There will be mentors who will
Sure.
correct you.
that
Okay.
can you got
Sorry, your voice is lagging a bit.
you can proceed.
Okay. So basically, your approach is definitely correct. You can do it like that as well. So basically, we are doing the same thing using the two-pointer approach. So implementation can be different again. So now we move on to the next question. That is problem E. Now what are
Why
we
do
given?
we have
Yeah.
sir,
Yes.
why do we have n plus 1 size for the prefix sum array? Just to put 0 in it initially, that's why.
Yes. Uh, I just initialize it with 0, and I have done it with one index. I have just used one based index.
Okay, okay.
So
Yes.
that is why I n plus 1. Every array I have created with n plus 1 size, so that it's one based indexing. Okay. And
Oh,
also
okay,
for
sir.
the string part, I have added a space for the first letter of the string, so that it becomes one index. So got it?
Oh, yes, sir.
Okay. So now I'll just move on to the next question. So what this question says, there is a grid. There is a grid of n cross m size, and there are W gorillas. So there are gorillas. So ith gorilla has a height of AI. And what we want to do, so there is a grid first of all of n cross m size. I'll just draw it. There is an n cross m grid. And there are W gorillas. Each gorilla has a height. Or rather, ith gorilla has AI height. This is given. Now we have to place the gorillas. I can place one gorilla in a cell, at most one gorilla in a cell. So here, suppose I place the second gorilla or something like that. I have to place the gorillas in the cells such that a number is defined, the spectacle. Okay. So spectacle, first we see what is a spectacle. So we are also given a number k. Suppose for this case 2. Just a minute. Okay. So for this k equal to 2, I'll assume. And this is an n cross m grid. So this is a 3 cross 4 grid. And I'll assume k equal to 2. So basically, we have to form subsquares in this matrix. In this n into m, this is a subsquare of length 2. We have to form subsquares of length k. So this is a subsquare of length 2. This is another subsquare. This is another subsquare. This is another subsquare. This is another subsquare. So we have to check over all the subsquares. For this subsquare, suppose for the subsquare involving, this is a subsquare. And this has, suppose, some of the gorillas. This has the second gorilla. This is the third gorilla. So this second and third gorilla size the sum of the height of the gorillas present in this subsquare will be the spectacle of this subsquare. This is the value of the spectacle of the subsquare. So for all the k size subsquares, for in this case we have, I'll just do it with another, and I can do. So basically this is one of the subsquare. This is another subsquare. This is another subsquare. Just mark it with different colors. This is a subsquare. This is another subsquare. So over all the subsquares possible in the grid, I'll just sum the values of the spectacles of the subsquare. This is called the spectacle of the total grid. So spectacle of the total arrangement is equal to the sum of the spectacles of all the subsquares. So for the subsquare part, the spectacle value for the subsquare part is basically for the subsquare part, it is the sum of the heights of the gorillas present in it. And for the total grid, we have to just iterate over all the subsquares of k cross k and add the spectacles of those subsquares. So now we have to maximize, we have to do a possible arrangement so that we have to maximize the maximum spectacle. We have to maximize this value. So are you clear with the question? So anybody has any doubt with the question? What the question is asking? You can ask me. Okay. So I hope everyone is clear with the question. Now we'll see the approach. So I'll do an example as well. I'll just quickly do an example. Okay, the first example seems good enough. We have a 3 cross 4 grid. N equal to 3, M equals 4, and we have 9 gorillas. All of them have height 1. So 9 elements. All of them have height 1. So I have to place these gorillas in this. These are 12 boxes. We have to place 9 gorillas in them so that we can maximize the sum over all. I'll just draw this square. Over all subsquares of length k, we have to maximize the spectacle value. So basically, how will we approach this problem? Basically, we will just see that if I keep the gorilla in a particular cell, suppose this cell, how many subsquares are passing, or rather of how many subsquares it is the part of. So answer will be multiplied by that because it will be part of. So for this every I comma jth cell, I'll just see how many subsquares it is part of. So definitely this thing is part of only one subsquare because the subsquare will move like this. Then this is a length k equal to 2. So basically, since k equal to 2, we'll just move. This is a part of 2 subsquares. This is also part of 2 subsquares by symmetry. Like this, it should be. And now for the center part, one this, one this. So it will be part of 2 subsquares. These will be part of 4 subsquares, and this will be part of 2 subsquares. So basically, I'm finding for each cell how many subsquares it is a part of. Are you getting the approach? And now, whichever cell has the maximum value of this, so that is the contribution that will be added. If I place a gorilla with height 1 in this cell, then 4 into 1 will be added to my answer. Suppose if this cell is considered, it is a part of 4 subsquares. So 4 into whatever value I put, whatever the value of AI I put, it will be multiplied with that, and that will be added to the answer. So what will be better to maximize the answer? So whichever cell is part of maximum subsquares, whichever cell will be part of maximum subsquares, I'll just put the maximum height gorilla into it to maximize the multiplication. Suppose in this grid, this 4, this is the maximum. I'll put the whatever gorilla heights we have, I'll put the maximum gorilla height into that, so that this is maximized. And the addition to the answer is maximized. Answer plus equal to this. So anybody has any doubt with the approach, you can ask me.
How do we compute the for ith,
That
its
that we'll
contribution?
discuss. That we'll discuss. If we have the contribution, then basically the problem is solved. That is fine, right?
Yeah, so both we have to basically sort and then multiply, right? Like
Yes,
maximum
yes,
you have to take.
exactly. So I'll sort these values in the decreasing order, these contribution values, and also the gorilla heights in decreasing order, and correspondingly multiply them until the gorillas are not finished. So I hope this is fine. Now we have to check one thing. What is the contribution of a cell I, j? How many subsquares it is a part of? So this is the main thing left in the question. So basically we can just put the right border at the ith cell, and we can just try to see where will be the left border at the ith cell once, and just check what will be the right border. This can be I plus k minus 1. Okay. So basically I am marking this as j and this as I. So it will be j plus k minus 1. Similarly,
Hello. Hello. Hello, am I audible? Hello.
Yes, you are audible.
Okay, okay. So it was a network issue. So I'll just resume. So basically, I'm putting the left border at j, then my right border can go up to j plus k minus 1. But this cannot exceed m minus 1. So if that exists, I'll just take the minimum. Whatever my right border can go up. It can go from j plus k minus 1, but we have to take the minimum with m minus
What
1.
is K here?
K is the subsquare length. So if I'm putting a subsquare of length k, this length is k. I'm finding out how many subsquares it is a part of. Okay, this I comma j cell, how many subsquares can it be a part of? So I'll just move the subsquare from here up till some to up to somewhere here, and I'll check whether how many values are possible for the left right displacement of the subsquares. And similarly, I'll just check the vertical displacement as well. Suppose the it can displace x in the horizontal direction and y in the vertical direction. So x into y subsquares, so it will be part of x into y subsquare. So suppose horizontally I can move x distance, and vertically I can move y distance with the subsquares. I'll just show you. This is my cell, and this is a subsquare of length k. I can just move it here. I can just move it here. I have a horizontal range where I can move it up to like this. I can just move it like this. Up till this, it's fine. Up till this, it's fine. But beyond this, I cannot move. Then it will not be I comma j will not be a part of it. So basically, I'm finding the right boundary. Right boundary. What can be its maximum value? This will be its maximum value. It can either go from j to j plus k minus 1, but it cannot exceed m. So we'll just take minimum with m minus 1. I am going with 0 indexing, so m minus 1 I have taken. Also, right border, this is the right border's max value. Also, right border's minimum value, I'll just find out. So right border's minimum value, this actually I'm talking about. This thing. This I'll just mark it. Something else. So for the rightmost value, or the minimum value of the right border. This is right border, and we have to find the minimum. This is the maximum, and in this range it can move about. So what will be the minimum value of the right border? So basically, minimum value can be either I. This has to be I at least. and minimum value cannot be less than k minus 1. So maximum of I comma k minus 1 will be the minimum value. Because if the suppose I say this is I, this cell I am considering, and k equal to 3. So if the right right border is here at 1, then this is not possible. This is not a possible subsquare. This has to be at least k minus 1. The right border should be at least k minus 1, because we are starting from 0, and since it has length k, it should be at least k minus 1, but it has to be at least I as well, because if it's less than I, suppose somewhere here, then this is also not lying in the I comma j. So similarly, for the right border, we have calculated what is the range. So the whatever the value, I'll say delta x, the right border can move from this value to this value, to the minimum value of the right border to the maximum value of the right border. So max minus, this is the delta x. Similarly, we can calculate delta y in a similar way. I'll just show you in the code. That will be the maximum minus minimum of the y values. This is the x values, or the horizontal movement I'm talking about. This will be the down border. I'll just calculate the similar way, in a similar way, for the down border. How many moves it can move down, or what maximum value it can reach in the downward direction, and what minimum value it can reach. So that delta y will be the difference. So basically, this I comma jth cell, will be part of delta x into delta y number of subsquares. Now if we have found out, for each cell we have found out this value, and we'll just sort it in the reverse order, and we'll also sort the heights of the gorillas in the reverse order, and go on multiplying corresponding values. So is the approach clear?
No, I didn't get the part. Why are you doing that? Like, uh, why are you finding the minimum value where it can go?
Okay, so I'll check that suppose this is my I'll just do that. So suppose this is my I comma jth cell, and I have a square of length k outside it, and we have the left border here. So is this diagram clear?
Yeah.
Okay, so I can just move this square. I can just move this square right, and whenever it collides with the border, I'll just stop. Okay, and I'll just also try to, if the border wasn't there, the right border was something like this. I'll just draw it again. If this had been present here, then I could have maximum gone up to this, end, right?
Yeah.
And if I had touched the border at any point, I will stop there. Okay.
Okay, but I'm not sure what do you mean by I'm moving that border.
So how many subsquares is this small little cell part of? Okay, I have to calculate
Oh,
that.
okay. Now I understood. We're just moving the border by K, right?
Exactly. I'll just whatever will be the displacement of this square in the horizontal direction, the border will also move by that distance.
Okay.
So I'll just calculate the range in which the right border can move. So that will give me the horizontal movement of the square.
So we'll just count how many times we are moving, right?
Exactly. How many times we can move in a horizontal direction with that k into k square.
Okay. So we're just counting the number of times we are moving.
Exactly. How many times we can move
Okay.
with that square so that it lies within that I comma j. So k into k square is covering the I comma j cell. We have to move in such a way. So that can be done by moving the right border. So right border has to be at j. Okay.
Yeah.
And if right border can maximum go up to j plus k minus 1, otherwise if it goes more right, then it will not satisfy that thing that the I comma j cell lies in it. So j plus k minus 1 is the maximum value.
Sir,
Yeah.
can
Did
you
you get
once
that?
show with a grid? Like, I'm not able to understand why k minus 1.
Okay, so I'll just show you. Suppose this is the grid and we are checking for this particular subsquare. Okay, this is I think 0 1 0 1 1 comma 1 comma 2. I'm checking for this. So basically this thing, this is the I'll just say that this is the extreme point of the square. If this line is the extreme point of the square, let's draw a line. This is one extreme. So what can be the maximum value it can go? This is suppose j. Okay, this is suppose j. Suppose this is j. This is j plus 1. I am at the 2 and this is 1. Okay. So if I am at I comma j, where can the right border at max go? This is 0. This
Of
is
course,
1.
3.
3.
Right border can go up to 3.
Up to this, right?
Yeah.
But suppose I had the grade up to this point only. This line was the grade. So I have to take then it cannot go up to 3, right? Then it has to
Yeah.
stop at 2 because 2 is the maximum point, right?
Yeah.
So I have just taken the right border can up maximum it can go from j plus k minus 1 to m minus 1. I have just taken the minimum of the two. This is the maximum right it can go, the right border. I'll just take the right border displacement. Okay, that is the displacement in the x direction that I can do. Are you getting my point?
Yeah.
So right border, suppose what can be the minimum value of the right border? It can go from here to here. Fine. For the minimum value, For the minimum value, this will be the square, so it can go up to 1, right? Leftmost.
Yeah, minimum 1, maximum 3.
Yes, exactly. So what is the displacement that I can do? I can move about from either this or this. Are you getting my point? I can move like this thing.
Yeah,
So there are two possibilities. That is 3 minus 1.
yeah, got it.
So similarly, we can move in the vertical direction as well. Horizontal direction I am representing by delta x, and vertical direction by delta y. So if I get these values, then delta x into delta y number of squares will contain this cell, right? Did you get that? Because for each movement in for each uh, movement in vertical direction, we can move like this into two ways. We can just form the square. Just move this from here, and once this square. This is the case for k equal to 2. So did you get what I am trying to say?
Yeah,
Okay, so and then after these values are calculated, how we are calculating the answer? Did you get that as well? By reverse sorting these values and reverse sorting the height values and just multiplying them. If anyone has any doubt, ask me right now. Everybody is clear with the approach? So I'll just discuss the code quickly. So now, uh, okay, so basically I'm taking n and m k, and I'm just initializing a grid. I've just commented out some part of the code during the contest, so that was in a hurry, so you did not write this part. So there are W gorillas. I just sorted the gorillas in reverse order. First sorted, then reverse order. Okay, that was the thing. And for each ij, I'm going in each ij of the ith row and jth column cell of the grid, and I'm just calculating what can be the maximum value or the displacement in the ith direction and the displacement in the horizontal direction. This is basically displacement in the vertical direction. This is displacement in the horizontal direction. So displacement in the horizontal direction can be calculated by this formula, and displacement in y direction.
Why is there a +1?
Okay, so plus one thing comes in the formula only. I'll just show you why. You can try to calculate this thing yourself as well for the ia comma j cell. What will be the contribution? So basically, this thing, this right border, I'll just observe the right border. Suppose the beginning is marked as j, and this the ending is marked as j plus 1. This is what I am calling the I comma j cell. So right border can go up to j plus k minus 1, and I'll to take the minimum with n minus 1 as well. And the
A minimum
right
with
border,
m minus 1, right? M.
Sorry, m minus 1. Yes, m minus 1. And for this part, for the for the minimum part of the right border, it can be j plus 1, right? J plus 1 comma, did you get this? J plus
This
1
is for
comma k.
the left border, right?
L- right borders minimum. I am considering the right border only. Right
Okay.
borders minimum value. This is the
Okay.
right border's maximum value. This is the right border's minimum value.
Mm-hmm. Got it.
So that is j plus 1 comma k.
Yes.
And whenever I have subtracted I could have done j plus 1 comma k. Because I have subtracted j comma k minus 1, then I have to add 1 as well. Did you get that?
Yes.
So similarly, the vertical displacement can be calculated I plus k minus 1 and taking minimum with n minus 1, and this thing also similar you can do. And this value, this multiplied by this grid ij has stored this value x into y. This is the number of k length subsquares it is the part of. Okay, then I just stored these values in a vector, and these vector I have reverse sorted, and for each gorilla I have just multiplied this value into this contribution into the gorilla height. Already I had sorted it in reverse order, and I have also sorted this contribution values in reverse order also. So this would be my maximum answer. Did everyone get it? How am I approaching this problem and the code part?
Yes.
Formula you can try yourself to derive yourself, that will just do better for you. So did you
What?
get the approach and how we are
Yeah.
calculating the thing?
I wanted to ask what topic does these sort of questions come in?
Okay, basically first of all the greedy thing. Okay,
Okay.
because you try to uh, whichever square is the very important squares, like the centrally located squares, they are part of many subsquares. You noticed that, okay, right?
Yeah, you're
So
right. Because they're from left
so
and right, both squares they will have, and bottom also, right?
exactly. So that should give you an intuition that we should calculate the contribution for each cell. What is the contribution for each cell? How many subsquares it is part of? Okay,
Okay.
so then I can just readily approach that whichever the maximum gorilla height, I'll give it to the maximum contribution square. So that greedy approach works, right? This is simple to observe.
Okay, so like I kind of like faced it like in the contest, so I couldn't like come up with a solution. So like, are there some similar questions on code forces also?
uh, you will just face it when you are practicing more and more, so that won't be a
Understood.
problem. Uh, just try to understand this problem in depth, try to derive the formula yourself, so try to again implement it if you have not done in the contest, so that
Sure.
will do good.
Okay.
This is basically, and contribution thing is important, that comes up quite frequently, so you can just uh, think in terms of contribution in some questions. So
Okay.
this is an approach you can take. So now we are going to move on to the next problem, that is problem F, and this will be the last problem in today's discussion. So I'll just go through it quickly, and uh, just a minute. Okay, so Everyone was clear with the previous problem?
Yes.
Okay, so the time complexity also I should discuss. The, the time complexity for the previous problem I'll just discuss quickly. Just open up the code. So there is a time complexity for sorting, that is this is W log W for the number of gorillas, and for each grid I am calculating this thing. This is a O of 1 calculation, so this can be done in total O of n cross m. So and then sorting the n cross m values. So this is basically n cross m log n cross m for the sorting part. That is the time complexity. Hope all of you got that. So that will work fine in the constraints of the problem. Now the problem number F. So basically we are given with n rectangles, and ith of it has a dimension of ai cross bi. So n rectangles. Rewrite. So we are given with n rectangles. Ith rectangle has dimension ai cross bi. So basically it's looks something like this. If I have a 5 cross 3 rectangle, this will be something like this. Okay. Now what we are told to do, so we can just choose a rectangle and choose a cell in it. We can choose a rectangle. Suppose we are given n rectangles, I can choose any rectangle and then choose a cell in it and just color it like this. And whenever I accomplish the that the task that I have colored a complete row, or rather if I have accomplished that I have completed a total column, if I have colored a total row or column, I get 1 point. 1 point for complete row color or column color. So basically what we'll do, first of all, we'll just see for the case of a single rectangle. Suppose this is a 6 into 4 rectangle. Now, how many minimum number of cells we have to color to uh, get a point? So can you answer that? How many minimum number of cells we have to color so that we get a point? To get a point, we have
Entire
to
row
color
or
and
entire column.
so what will be better in this case? Entire, should I do this or should I do this?
Uh, Column wise we can do, but
This would be
when
better
yeah.
because I have to color just 4 things and I'll get a point. Otherwise, I had to color 6 things and I would get a point.
Yes, yes, got it. Yeah.
So if a I comma bi is given, I'll just, you can observe that we can just color this thing, the minimum dimension among AI comma BI. And what will be, this thing will be colored, right? After the first step, we'll require just, how many steps will be required? These are the number of steps required, minimum of the dimension. Whichever is less, we have to require that many steps to color that, and we'll gain a point, right? And what will be the happen to the rectangle? This thing is already colored. So basically, we are left with a rectangle of 5 into 4. A 5 cross 4 rectangle. This part is only left. So now what is happening? If we color using the minimum of AI comma BI, the maximum value among AI comma BI gets reduced by 1. Did everyone get this point?
Yeah.
So first, we'll color using the minimum dimension, and the maximum dimension will reduce by 1, right?
Also, can you say example if there is a 1 cross 1 square, what will be the case then? Will it increase score
Okay.
by 2 or 1?
Okay, there is a 1 cross 1 square. So basically what we'll do, I'll just suppose for this part, you can just assume that if 1 cross 1 is reached, then we can just add 2 to the score, right? Or actually we can do something better, that here A equal to 1, B equal to 1 for the 1 cross 1 square. So when we just take the maximum, when we just take the minimum among them and just reduce it, suppose this both are minimum, so I can just reduce anyone. A equal to 0 and B equal to 1. So I just get a imaginary rectangle of this dimension, right? 0 comma 1 for the next step, and I can just reduce the I can just, with 0 cost, for the next iteration I have just 0 cost, but the score will increase by 1. So for the next iteration, it will just, in the next iteration it will be taken care of. Did you get that?
No, can you agree? Go through?
Okay, so first A equal to 1 and B equal to 1. So in the first iteration, I just reduce A with 1 cost, and my score increases by 1. And in my next iteration, after this, what will be the minimum among A and B? That will be added to the cost. First 1 is added to the cost, then 0 is added to the cost, right? And my score increases by 1. So first 1 is increased here with 1 cost, and then with 0 cost I can increase 1. So basically with 1 cost only the 2 is getting increased. So
Okay,
are you
got
getting
it.
my point?
Yeah.
Yes, that will be taken care of by the by this algorithm only. Okay.
Why did you reduce the one? I mean, because you colored like one cell.
Okay, so basically this thing works for every other case. Suppose this thing I have. So first I remove the minimum dimension. This is 3 cross 1. I just remove the uh, one cell, and I just add 1 to the score. I get 1 because one column is already colored, or one row you can say is getting colored. Then
Mm,
also I am left with a 2 cross 1 grid, right?
right.
Then also I do, okay, then I have 1 cross 1 grid. So I suppose that I assume that I am coloring it with 1 cost, and I am getting 1 in the point, and after that I am left with a 1 cross 0 grid, and that then I can just means extrapolate this algorithm. And what is the minimum value? This is 0 and this is 1. The minimum I think I can add to the cost what I was doing previously only. So with 0 cost I get a 1 value. So after that both become 0 and I have to just exit. Did
Got
you
it.
get that? With
Yeah,
0 cost I am getting 1. After 1 comma, actually I am getting 2 from 1 cost only, but I am just doing it in extra step, that with 1 cost I am getting 1 and after that 0 cost I am getting another 1.
okay, okay.
Okay, so basically this will be the algorithm for this problem. So again this is for only one rectangle, right?
Yes,
So for one rectangle with, suppose a cross b is the dimension of one rectangle, what can be the maximum number of points that I can get from this? A plus b, right? Because it has a columns and b rows, or rather a rows and b columns. So a plus b row plus column, so entire row whenever it gets color we can get 1 point. So maximum a plus b points can be obtained from a cross b dimension rectangle, right? Did you
yes,
get this part?
yeah.
Okay, so what I'll do, we have n rectangles. So suppose from 1 to I and then n. We have n rectangles, and suppose till the I minus 1th rectangle, I'm going with a DP approach. Okay, it will require knowledge of DP. So
I have
what
one
will,
doubt.
yes.
So if we okay, this is like if we just sort the rectangles by dimensions, for each rectangle we can get like a plus b points.
So
So
what will be the basis of sorting? What will be the basis of sorting?
row and column, maximum row, maximum column. Like max points
So
we can get with a plus b, right?
okay, so maximum, what can it contribute to the maximum score, right? That you're taking as uh, the
Like
sorting criteria. What will be the sorting criteria?
so I have the a and b, right? Length and breadth.
Yes,
So
of
sorting criteria
10
can be
rectangles.
by row first, and if there is a tie, then by column.
So you are sorting by length of the rows, right?
Yeah.
Okay, but uh, I should show you an example. I'll just show you an example.
Like in this case, you've highlighted n is 2 and k is 100, right?
Okay,
From
this won't work because this is case 200,
Yeah.
400, so
Suppose
100
this one
this.
which you've highlighted. So in this
Yes,
case,
yes.
2 cross 2 is there, 3 cross 3 is there, 4 cross 4 is there. Suppose this
Okay,
is sorted, then 4 cross 4 will come first, 3 cross 3, then 2 cross 2. From 4 cross 4, we get 8 points. 3 cross 3, we get
but
uh,
but
6 points.
do you see that we have to minimize the cost as well? We have to earn k points and we have to minimize the operations. So coloring operations should be minimized. So 4 cross 4 grid, to get a point you need, first of all you need to color 4, right? 4
Yeah,
at
8
least.
operations I will need.
No, total you cannot get 8 points with 8 operations. So
Okay.
basically what will happen, I just show you. This is a 4 cross 4 grid.
Yes.
First you need to color 4 things to get 1 point.
Okay. Right.
And then what we will do, we'll just go with the minimum thing. Then we are left with a 4 cross 3 grid, right?
Yeah.
Now we'll just color this 3 to get
Okay.
another point.
Okay, got it. Yeah.
And then I will just color with 3 to get another point, and then this 2 to get another point, then this, and then I suppose this and this.
Okay, so one rectangle will have like these many
So
gates.
basically first initial cost will be also more, so you cannot sort on that criteria, because for a 4 cross, suppose k was 1, okay, k was 1 in this case, not 11.
Hmm.
So if I take the 4 cross 4 grid, I need 4 operations to get 1 point. I have to just cross 1 point with the minimum number of operations.
Right, right.
So
There I
it
go.
will be better with 2 cross
2
2.
cross 2.
Okay,
Yes.
okay.
Right.
So we'll go with an
An
DP approach. Yes,
Another thing,
yes,
Shubhankar, like I tried something different in the contest.
yes, yes.
I did a binary search on the number of operations.
Okay,
Uh, where I took, say, example low, zero, high at, say, example I dot first, uh,
yes.
length into breadth of everything. And I designed my check function in such a way like I pick up the dimension which is the least currently. Uh, I
Okay, did
kind
that work?
uh, I am kind of stuck in the seven sample. So
Okay, okay, that won't work. I think that won't work, because I'll just I think in this sample it would fail, I think.
yeah,
Okay,
this
I'll
sample
just
only I wanted to discuss. 35th.
okay, okay. So what binary search logic you are implementing is that you do a fixed number of operations, right?
Yes.
So can you maximize the answer for this number of operations? So how can you maximize the answer for this number of operations? How do you approach that?
Maximize answer. So what I see is like pick up.
Suppose I use k operations
Mhm.
for the binary search, or so how do you maximize the number of rows that you can maximize the number of points I can gain with these number of operations?
That would be like pick up the least dimension that is there among all length and breadths that are present. Even say example, there is a breadth with say two. So pick that up, exhaust it, like reduce that one, use
Okay,
that completely, and then move on. Insert a new pair in the multiset with the updated row and column, and then keep on doing that repeatedly.
okay. So I have
My
to
approach
think
is like
about that.
points greater than, yeah. I thought it could be done with binary search because I saw that predicate monotonicity. Disconnected.
So whoever had asked the doubt,
Hello?
we, hello.
Yeah. I did. I pasted my approach in chat, but maybe we can connect post
Okay,
this one.
see your approach afterwards, after the
Yeah,
meeting.
sure.
We'll
Sure,
have-
sure.
I can just discuss my approach once.
Yeah.
Okay, so I'll just go with the DP approach. So whenever I am at the ith rectangle, suppose this has dimension ai comma bi. What can we take away from this? We can take away either score from 1 to ai plus bi. This can be the score taken away from this, right?
Yes.
Anything from 1 to ai plus bi. I can choose that number, right?
0 as well, right? If you don't want
Okay,
to pick this.
yes, obviously. 0, yes, you can just consider 0 as well. 0 to ai plus bi. So accordingly, we will have costs. Suppose I am taking just one. So then I'll just add minimum of a comma b and just reduce the maximum of a comma b by 1, right? And for 2, I'll just again require the updated minimum of a comma b. I'll just add it. So that will be the cost, right? Did you get the cost for 3? And up till I can do it up to ai plus bi. So for this code from this particular rectangle, I have to add this and just update a and b accordingly. Just we have discussed it. How we will update? We'll update the maximum by -1 and just add the minimum to the cost. So are you getting how we are calculating the cost of this of a particular point from a rectangle?
Are we storing these answers as well? Anyway.
No, we are not storing. We'll just calculate it running. Okay.
Okay.
For one score, we need this much cost, right?
Yes.
And then I will update the maximum among A and B by 1. I'll just reduce it by 1. Basically, what we are doing in the rectangle part, this part is cut off. And we are left with this part. This part. And for the second score, with the I'm just doing with the updated A comma B. With the updated A comma B, I'll just make another cut. And I just updated the maximum among them by 1. So I'll just reduce it by 1. And for the next cut, suppose B was less, then I'll just make this cut. So I'll just calculate it by running in the loop only. So first I add this as the cost, and upon this cost I add this. Again this I add, so and so on. For the particular score, I have a particular cost. Are you getting this?
Which form of data does it fall
If I
into?
want to extract
How can I visualize it? How
your
can
voice,
visualize it like
your
transition
your
equations?
okay, I'll just show you that. Can you? Okay, so transition. I'll just show you. For this thing, suppose up till I minus 1. Okay, so important thing is the constraints of this problem. Another thing that I would like to impress upon. Constraints is n is less than equal to 1000 and k is less than 100. And the dimensions also are less than 100. So ai plus bi is maximum. Ai plus bi will maximum go up to 200, right? And we have to find the minimum value, minimum cost that we have to pay to go up to score k or more, at least greater than equal to score or get we have to just satisfy this condition that score is greater than equal to k. Suppose till I minus 1th rectangles, suppose I have used I minus 1 rectangles and I have obtained j score. What is the minimum number of steps? Okay, what is the minimum cost I have? This is kind of a knapsack problem. Are you getting that? If I have
Yeah.
up till I minus 1 and score j, I minus 1 things I have already taken into account, and I have a score j that has a minimum cost. And now I can add these numbers to my score with particular costs which I have to calculate, which will be calculated by this method. I can add these scores. Suppose I minus 1 comma j is reachable. So I minus j. So whenever I am taking the ith rectangle, I comma j plus 1 is reachable with I minus 1 j plus cost that I need for the ith rectangle and j points, or rather 1 point. From the ith rectangle, I am taking 1 point. Are you getting this transition? These cost values are these values only. Cost of 1 will be calculated by mean of a comma b. Cost of 2, I'll add the updated mean of a comma b and just update a b accordingly. So cost, this thing will be calculated. So this can be the transition. In general, transition would be like this. I'm taking the ith, and from the I comma j was reachable, I minus 1 comma j was reachable, and I'm taking k score from this equal to I minus 1, and from the ith rectangle I have to take a cost of k. Are you getting it? To make j plus k from j up till I minus 1, we can just add the cost of taking k points. So are you getting this transition?
Yeah.
The knapsack part was not clear. I only understood till, say, example computation for a particular rectangle. Can you repeat?
Okay. So what is the thing? I can take, whenever I am at the ith rectangle, okay,
Mhm.
I can take a score of 1 from it, 2 from it, 3 from it, and up till like ai plus bi, right? This is the maximum score I can obtain from my ith rectangle.
Correct.
This has some cost. Suppose cost of I comma 1. We can calculate this cost by the method I showed you.
Yes.
This has a cost, right?
Yeah.
So suppose I am taking k value from ith, from the ith uh, rectangle. I am taking k value. So whenever I am taking k value, I have to give cost of I comma k, right?
Okay.
So if I want to add k value to my previous answer, so previously I comma I minus 1 comma j was there, okay, j score was already there.
What
Is this
do
clear?
that current DP states represent?
This up till I rectangles,
Hmm.
I will have score j plus k,
Okay.
and I have taken k score from it, okay.
Hmm.
From the ith rectangle, I have taken k score,
Okay.
and I have up till the ith set, I have the score j plus k. So up till I minus 1, I have to have score j,
Hmm.
and j plus k will be formed, and for that I have to pay the cost.
Yeah, provided current rectangle has that till k, like limited by
Yes,
a
yes,
plus b, right?
exactly. Exactly. This k should be between these values 1 to ai plus bi.
Okay.
Suppose k is here. Is this transition? This is kind of similar to knapsack, right? Because we have to pay a cost to add a particular score. We have to pay a cost to add a particular score at that point. Are you getting the similarity with the knapsack?
Yeah.
Okay. So basically, this was the approach I used. I'll just show you the code once. It will be more clear if I show you this. So n is 100 and k is maximum 100. So we could have done it with as per the constraints of the problem. We have n is 1000 and k is 100. So I just created a global DP, and whenever I take nk as input, I just initialize the entire DP array with 180. Okay. And one thing to note here is DP of 0, 0 is 0. Means up till the 0th index means I have not taken anything and I have a score 0 that requires 0 cost, right?
Yes.
Yes.
Okay. So now I'm just taking the input of the rectangles a comma b, right? Now I just made a copy of a and b. Okay, a1 plus b1. I'll just show you why I have made a copy. A1 and b1 are the copies of a and b. Okay. So I loop up to a plus b, right? Because this can be the what are the scores that can be obtained from this particular rectangle from 1 to a plus b, right?
Yeah,
Yeah.
correct.
Okay, so what is the cost I have to add? Minimum of a comma b,
Yes,
Right.
and I have to reduce the maximum by 1 because the dimension have now changed for this rectangle.
correct.
Yeah.
For the next iteration, when I need 2 score from it, suppose like this I have. Suppose I have a square of 3 cross 3. Initially, I'll just reduce it to a 2 cross 3 square, right? It will become a 2 cross 3 square. 3 cross 3 square, this will be cut off, and a 2 cross 3 square will be formed. For the next iteration, I need only two things. 2. So I have to update A and B, right? So I'll update the maximum of A and B by -1.
Yes.
I was explaining
Yeah.
back then.
Okay, okay, correct.
Okay. So for the next time, I have to take the minimum of a comma b for the updated a comma b, right? For score 2, right? For score 2. So I am taking j score from this ith rectangle. I am taking a score of j. Basically, this is clear, right? And sum is the cost I have to pay. Getting this?
Yeah, what is this L loop doing?
Okay, I'll so now I have to check whatever values were present in the I minus 1th state. Now L loop. L loop is to iterate from all the values to all the values of the I minus 1th state. I minus 1th state, whatever, suppose this I minus 1 comma L was possible, right? That is not equal to 180. That means it was possible, right?
Correct.
So if that was possible, then L plus J is also possible because I am taking J from this.
L plus J. Yes,
L
L
was
plus J is
possible
possible.
till I minus 1. L was possible till I minus 1. So till I, L plus J will be possible.
One second.
I
Till
minus
I'm
till I minus 1, L was possible.
correct.
So till I, if I take J from this ith thing, then
Yeah.
till I L plus J is possible.
Yes, yes. And this first condition, what is that? DPIL is equals to minimum of.
Okay, okay. First condition is if we take 0 from this ith thing. So basically dp I comma L
Mhm.
will be minimum of dp of I minus 1 comma L. I do not take anything from it.
Okay, okay.
So
Previous state
if I
repeated.
exactly, I do not take this rectangle at all.
Okay.
Or if I take a score of j from this rectangle, I could have just looped j from 0 to a plus b minus 1. That
Correct.
could
Yeah,
have
that
done the
would
job.
also have done the.
That would reduce this thing to a
Mm-hmm.
single thing. Okay. So basically that can be done. But the concept is if uh, if till I minus 1 L was possible, then up till I L plus J is possible.
Yes, correct.
And that will be I minus 1 comma L. What was the minimum cost? Plus the cost here we have to give.
Yes.
So did you get what the DP is doing?
Yeah. Yeah.
Okay, so another thing, I cannot use A and B here. I have to use the copies because A and B are updated inside this. So I do not want this to be updated every time, this loop thing. So I have used the copies. Okay, did you get that?
Understood. Yeah.
Okay. So now I have to get minimums. After using n rectangles, I can just iterate over all k or greater than equal to k I score I need. Okay. So I'll just iterate over all uh, all i's from greater than equal to k up till the maximum value, and I'll just take the minimum of the dp values. And if the answer was not updated at all, so this answer was not possible. Otherwise, I'll print the answer. So did you get this?
Yes.
Yeah.
Okay. So the time complexity for this problem was basically, what did I do? First, I iterated over n, then ai plus bi. So ai plus bi was less than equal to 200. So that will be given as 200 into n into again a L loop I have done over 200. So that would be nearly 4 into 10 raised to the power 4 into n, and n is maximum 1000. So 4 into 10 raised to the power 7 iterations. So basically complexity is n into k, right?
And how did you come up like I have to do knapsack something related to knapsack here? Was this
Okay,
constraint
okay.
on the K and all?
Okay, so basically k was small enough, right?
Mm-hmm.
And we can iterate n was also small enough. So something like n square could have worked, or n into k square could have worked.
Okay.
So basically that is also a hint. Initially I was also approaching the problem with a greedy approach, but the binary search thing also came to my mind, so I won't reject that. But uh, as you said, I had written some code and it failed, so I thought that DP could have been done. And DP, the beautiful thing about DP is that it cannot give wrong answers, right?
Yeah. Yes.
It checks for all
All
possibilities. So
states. Yeah.
yeah, so I thought of the DP state. What could have been the DP state? Suppose I have the score, particular score, which I have to reach. What is the minimum cost I can reach that score? I thought of that DP state, and
Okay.
the
So this is how knapsack came, particular batch size and max
yes,
score.
yes. So basically, I have a cost to add a score. I have to give a cost. So I could have just iterated over the scores because scores are small enough, and the cost can be added like this. Minimum cost I'm storing in the DP. So the DP value will be the answer because that is the minimum cost. So did you get this?
Yeah.
So that is fine, I think, for today.
Just one thing, can you like also like if you're not discussing, can you at least share the your